Hey guys, this is Ms. Lockhart, and this is your physical science lab on density. So you guys need to make sure you have your green physical science book out, the student page book. And we're going to be working on pages 18 through 21. There are two different sections to this lab. There's density of solids and density of liquids. Remember that density is how much matter is packed into a substance. So the more matter that's packed in, the denser your substance is going to be. Okay, so we're going to look at solids and liquids and their density. You guys should have gotten your K-12 physical science lab kit. And you're going to need a couple of things from there. You're going to need this thing called a graduated cylinder. This is this big thing right here. And then the other thing you're going to need from there, it came in this box. And it's your digital scale. Okay, it looks like this. And you just will take the top off of it and make sure that it came with batteries as well. So those are the two things from your lab kit that you're going to need. And then for the density of solids, you're going to need 5 random household objects. So I just picked some random ones. The key for these is that it has to be able to fit down inside of your graduated cylinder to work. Okay? So that's for the density of solids. Just find 5 solids that are small to fit in the graduated cylinder, and they can't float in water. They have to be able to sink to the bottom. For your next thing, for the density of liquids, you're going to need 3 different things that are found in your house. You're going to need cooking oil. You can use any type of cooking oil that you might have in your pantry. You're going to need, it says syrup, so if you want to use your maple syrup, I'm using this Caro syrup because it's what we have. It just has to be thicker than your water and your oil. And then the third thing you're going to need for your density of liquids is water. This is just water that has green food coloring, and you'll understand why I put food coloring in it later. It does not affect the density. And you're going to need your graduated cylinder again for the second section for your liquids. Okay, so I'm going to do a couple portions of each of these labs, and then after I finish, I want you guys to get your lab book out and to do this on your own, and make sure you guys answer the questions after both sections and show them to your learning coach. Okay, so on page 18, right here, it looks like this. I'm on page 18 of the lab book, and the first question just tells you to get, the first part of the procedure just tells you to gather your 5 household items. And then once you do that, you need to list the 5 items on the density chart, which is on page 19. So if you look at my density chart right here, I've listed the 5 items that I just gathered. One of them actually I took from the lab kit. Is these magnets, because I knew that they would not float in water. So all you do for your second part of your procedure, just list the objects on your lab book. Right here, just list them. Okay, once you've listed the object, this is when you need to get out your digital scale. So your digital scale looks like this, and you'll need to turn it on. When you turn it on, there's a button on the far right called Tare, and that's going to be the key. It's just like when you step on a bathroom scale, you want it to start at 0. You don't want it to start at like 1 or 2 or 3. You want it to start at 0. This measures everything in grams because we measure mass in grams, okay? So what you'll do is when you turn your scale on, you'll set it on a flat surface. And mine is not at 0, so I'll hit Tare. So now it's at 0, okay? And your question number 3 in your lab tells you just to get the mass of all 5 of your objects. I'm going to do a couple right now, and then when you do yours, make sure you do all 5. So my first item that was on my list, it doesn't matter which order you write them down in as long as you keep the mass and volume straight. So my first item is this fun little fork. And my scale is at 0, and I set it on it. And it gives me a mass of 21.5 grams, and I'll write that down. Make sure you use the decimal points. Don't round them up, okay? Use the decimal points. I'll take it off, make sure it goes to 0. My next item is a glue stick. I'll set it on there, and it says 13.2 grams. and so on and so forth. So you'll get the density, you'll get the mass of all 5 of your objects, okay? That's the first thing to do. So get the mass of all 5, and then you don't need this scale any longer. Okay? Once you get the mass of all 5 objects, you're going to need to pull up this graduated cylinder, okay? It tells you in question number 4 to fill the graduated cylinder up with 150 milliliters of water. On the right-hand side, there is a measurement for water. This is in milliliters, okay? The key with measuring liquid is liquid has, I'm going to show you, liquid has a certain thing called surface tension that liquid deals with. Alright, so when I fill it up to 150 milliliters, the key is when you need to get eye level to the liquid. Liquid in a graduated cylinder is going to have a curve, and you need to make sure that the bottom of the curve is at 150. So you don't want the top of the curve, you want the bottom of the curve to be at 150 milliliters. It's called the meniscus. You want the bottom of the meniscus at 150 milliliters. And you measure water at the bottom of the curve. Alright? I need to dump a little out. Okay, so what you'll do, once you've got the mass of all the objects and you have 150 milliliters of water in your graduated cylinder, you're going to drop the objects in this graduated cylinder one at a time. So what you're going to do, you know that your line started at 150 milliliters, and I will drop my fork in, and I'm going to take the new measurement of water. It might be smart to kind of write the 2 numbers on a piece of, kind of above your chart. After I dropped it in, my new measurement was 164 milliliters. So you have to do a little math, okay? You'll have to take 164 milliliters, subtract it from the original 150, and my answer on my calculator tells you, you can use your calculators, that's one thing you need. It tells you that the volume of this fork is 14 milliliters, because I took the 150 that I had in here, and I subtracted it by with my new water level. Alright? So you'll stick your answer in the volume section of your chart. The volume says centimeters cubed, and that's centimeters cubed is the exact same thing as 1 milliliter. Centimeters cubed is what we measure a solid in, but it is the exact same measurement as a milliliter. Once you find the volume of your first object, you're going to do it for all the other ones too, okay? So I'll do one more. Fill my graduated cylinder to 150 milliliters. And I'm measuring from the bottom of my curve. Drop your object in. Aww. Can't use that one, can we? Looks like I've got to get a new one. Didn't know it would float, huh? Tricked ya. Alright, let's do another one. Alright. I know that this magnet is going to be more dense than water. It's going to sink in this. So let me take the mass of my magnet. It was 83.3 grams, and now I'm going to drop it in. So I drop it into my 150 milliliter full graduated cylinder. And my new volume, it only went up 10 milliliters. My new volume is 160 milliliters, okay? 160 minus the original 150 will give me 10 milliliters. Alright, so what you'll do, you guys will continue this procedure for all 5 of your objects. And if you had something like me and you had one float, just find another one. So I'd have to go around the house and find another one, okay? So eventually you're going to have your whole chart filled in. Right now mine isn't filled in, but this is, now here's the key. Once your chart is filled in, we're going to use a formula for density. And I'm going to tell you the formula for density. Ready? It's the density formula is, I'm going to highlight it for y'all. The formula for density is back on page 18. It's the highlighted orange. Its density is mass divided by volume. Mass divided by volume. So I'm going to show you how I find the density for the 2 objects that I did, and then you guys will continue the same procedure for yours. So for example, my fork, I know that the mass is 21.5 grams. And I know the volume is 14 cubic centimeters, which was the same thing as 14 milliliters. So what I'll do is I'll put these into my formula. So your formula looks like this. Your formula is density equals mass divided by volume. And I'll do the formula for my, I'll do the math for my glue stick. I'll show you how to do it. No, I'm sorry, for the fork. So the formula would be set up like that. The fork is 21.5 grams, that's the mass, and the volume is 14 centimeters cubed. And you just plug these 2 numbers into your calculator. So I take 21.5 divided by 14, round it to 2 decimal points. My answer that the calculator gave me was 1.54 grams divided by centimeters cubed. So this was my density. I just did a little math problem. I'm going to skip to the bottom of my chart because we knew the magnet worked, and I'm going to do the formula for the magnet as well. So the magnet is the mass was 83.3 grams. The volume was 10 centimeters cubed. And I take the 2 and divide it. I'll take 83.3 divided by 10. And my density is 8.33 grams over cubic centimeters. So you guys should fill out your entire chart with all 5 of your objects, and I just did 2 for you. And you guys can be creative about the objects you use. What you'll do after that is you guys are going to look at this data. You're going to look at this data in this chart. You're really going to be focusing on this last column, on your density column. And you're going to analyze your data. There's 4 questions to answer based on this data that you guys got. And when you, after you finish answering them, you show them to your learning coach, okay? Once you finish this section, then you'll need to turn the page to page 20, and we're going to talk about the density of liquids. We know that liquid has mass because it is one of our 4 states of matter that we just talked about on Monday. Or Thursday. It's solid, liquid, gas, and plasma are 4 states of matter. So this is going to have density. Even though it might not look like it's going to, it will have density. Alright, so here's the procedure for this one, and I want you guys to do this at home just because it's really cool looking. I'm going to go ahead and do this whole procedure, but you guys can do this at home. If you want to use the food coloring for your water, it'll make it easier to see the different layers that you're going to have in here of liquid. So the first thing that you're going to do is you need to measure 1/4 cup of water in your measuring cup. I'm going to actually dump this out so it's 1/4 cup of water. I'll dump it in here. So we need 1/4 cup of water in our measuring cup. This is just going to be my excess. The same thing is true with water in this measuring cup. You measure to the bottom of the line. You measure to the... Alright. So I've got 1/4 cup of water in here, and I'm going to pour this. It tells you just to pour it into your graduated cylinder. Okay? That's step one. The next step says measure 1/4 cup of vegetable oil. So I'm going to put vegetable oil in my measuring cup. If you have a glass measuring cup like this, it's going to be better. Then you don't want to use one of the solid measuring cups. You need to try to use a glass one. Alright, I've got 1/4 cup of vegetable oil. And the deal is you need to slowly pour this into the graduated cylinder, okay? You don't want to dump it. If you guys have ever seen salad dressing, this is the same property. This is why you have this shake up salad dressing. Alright. You guys see right there? My final step is to measure 1/4 cup of maple syrup. This is Karo syrup. It's a corn syrup. It's the same type thing. That one's not opening. We're going to try the next one. That one's a little shut. If you guys have some syrup, any type of syrup at your house, you can use whatever you have at your house. You can use maple syrup or Karo syrup. So you do a 1/4 cup, and I'm going to pour it slowly again. It's going to be thicker. It's a term we'll talk about later called viscosity. It's a thicker substance. You'll watch it go in. So if you look at your graduated cylinder, you should see 3 different layers of liquid. Okay? They're all 3 liquids, but they have different densities. If you see, there's a top layer, a middle layer, and a bottom layer. Number 5 in your procedure tells you to, on page 21, there's a picture of a graduated cylinder. And number 5 asks you to take colored pencils or crayons or whatever, and you'll need to color the 3 different layers, which is why I had food coloring in the green so you could see it. And then there'll be questions to answer about which liquid you think has the greatest density and different. So you need to remember the vegetable oil was at the top. Think about your salad dressing, how the oil always is at the top. Vegetable oil was at the top, water was in the middle, and that thick Karo syrup or maple syrup or pancake syrup, whatever you have at home, that's your bottom layer. So you need to answer questions based on which level is what. It tells you too in number 4. I think it's number 5. When you color this graduated cylinder with your 3 different layers of liquid, make sure you label which one's which. So if I would color this in, I would say, I would give you a top and a middle and a bottom layer. I'm just going to do it real. And you need to make sure that you make sure that you need to color them and you need to label them. And based on that image, that picture that you guys just drew, you'll need to answer the questions underneath. This is a neat experiment to show, like if you have like younger brothers or sisters or whatever, it's cool just to look at it. And I don't want you to try it with this, but if you were to shake it up and let it sit and you would come back in a few minutes, it would separate out again. If you're brave enough to try it and your parents are okay with that or your learning coach is okay with it, but there's no lid to this. So it is pretty cool to watch it if you were to shake it up, and when you come back, it will separate out again. It's pretty awesome. So this shows you that there's different densities of liquids, even though sometimes all liquids might seem the same. So that is your density lab. Remember, you need to have the student page book, not the teacher page book. The student page book, and we start on page 18, and it goes through page 21. So you'll talk about the densities of solids, and you'll talk about the density of liquids. I want you to do this on your own, because this is something you'll need to show to your learning coach, and you'll have to tell me that you did it, okay? And I'll ask you to check off that you did it. And it's fun to do experiments, so that's your density thing. If you have any questions, you guys can email me. But that's it. Y'all have fun.